I'm live. Awesome. Well, let's say hello in chat. I'm sure it won't be a little premature for people. Where's the video URL? Let's just grab that and tweet that. Say hello if you're lurking, I guess. Righty. I suppose I should... what I could do? See if I can add a photo in of the plan. Add an image. So then anyone who's joining can see what it is I'm soldering. Oh, well, let's scale that down a bit, because now you can't see anything else. I don't know why OBS decided to make that bigger than the screen. Have I scaled that or just... yeah, I'm scaling it. Okay. I think I'm scaling it. Right, there we go. That might be too small. Let's put that over there. Well, good morning and hello. Doesn't appear to be anyone on yet, so... I will keep my eye on chat. Right, let's support that from underneath. These have a tendency to drop out. Iron had gone to sleep, which is probably best for everyone's safety. No, that's not what I meant. Okay, so that's a bit on the long side. And irony is the other one's on the short side. Okay, let's... So I want that to be here. Let's see. See, I could probably loop it round from there. We still have too much. Okay. Strippers are now working far better than they were yesterday. I made a tweet on this. There was a metal dag right in there, and it was basically just cutting through the wire. I guess it's what you get from really cheap tools, right? So once I'd managed to chop that out, this is now working a treat. There you go. Hashtag look after your tools and you get much better results. and these are stripping a treat now. It's fantastic. Right, so I was planning on seating that wire in there and then going around this little bundle here to this. If I put it on the bottom side of this, there we go, just like that. Right, I'm going to solder this side because I suppose it's going to be the trickier one. And remember, I can turn the board so I don't need to hold my soldering iron at any weird angles, which makes life far easier. Needs more solder. Let's feed the joint first. Oh, and it's heating up the other joint. That's why I'm supporting the connector from below, because yesterday I had a number of times when, as I heated the joint next to it, connector dropped out the bottom. Not a lot of fun, that. Got quite frustrating. So this time, by sticking, I figured this out yesterday, a little shim just made out of these DuPont housings actually, that stops the connectors falling out as they get warm. Right, and then I can, this one's a bit easier because I can push it down in there. It's already held in quite nicely. So when I've finished soldering this, I'm going to test the connections, have a quick verify that it is really what I meant. Where's the solder going? Is it being, oh, it's being wicked up by the next joint. Not quite. It doesn't matter really, because that whole bar is basically a battery. Oh, not battery, sorry. That is the regulator output or boost output. So that's a boost output voltage, 6 volts for the servos. I'm just going to check. Yeah, that is still insulated, but you know what I might do? Can I... Slightly worried about that little point there, but I will obviously use a multimeter and check for continuity where I do want it, and make sure I don't have it where I don't want it. So before I go and use this, as well as clipping off all the extra bits. Okay, so what's the next connection? Next connection is going to be, I wonder if I can get this to show a pointer. I don't think there's a way to get OBS to show a pointer over an image box. Okay, so the next connection I'm going to make, let's move this camera as well so you can see more of my work. Sorry if I was working off screen just now. There we go, that's better. Right, so the next connection to make is from this point to this pin here, and that's a Raspberry Pi GPIO pin to a FET. So let's we're going to use a yellow cable. So on the diagram, yellow is basically Raspberry Pi signal. I think that's a reasonable convention. So I've gone with colour code on the diagram, and I've tried to get the same colour code in the actual physical wires. And I could just strip off a couple of millimetres more of that one. So, bit of background on this. I am making a Nerf gun firer for my Pi Wars robot, which, even if there is not Pi Wars this month, for obvious reasons now, I will still be carrying on the build. I admit I paused the build for a while, everything went a bit, but I'm going to carry on the build, perhaps at a slightly less frantic, manic pace, and I guess after that I get to spend time, well, first obviously getting this tested and in, then we can practice actually firing, and then also I can consider the code. In terms of code, I have a new trick. So I was at the very beginning of this, and at the PyWars mini conference, I talked to some people about doing simulations. Now, actually, I think I've been beat to it. Was that Lorraine who's beat me to with some amazing simulations, and me and one of the schools people were also looking at some simulations. And I'd come up with something in Python, which was using a Python 2D physics library. It was okay. It was a bit of a pain, and it wasn't quite right. And I'd spent probably more time just trying to integrate it all, getting an environment, than really think about the algorithms that are running it. Okay, that's really tricky to get that round. So I guess from what happened on that, I found Unity. Now, Unity, if you've not come across it, it's a 3D gaming or simulation platform. Now, I used to do game programming. It used to be my thing, even professionally. So I guess I took to that environment pretty well. It's C#, it's not Python, but that doesn't particularly worry me. I'm polyglot enough with my languages that I don't think language A and language B is generally a problem. Right, I'm going to use some blue tack to hold this thing in place. And I've already figured out through some experimentation how to import models from Fusion. Now, I probably think importing my whole robot model is a bit much because the poly count is ludicrous. So I'm going to kind of make a low poly, maybe box with a camera and wheels version of a robot. And it's not going to really do full physics modelling of the wheels, I guess. But what it should be able to do is line of sight camera modelling, which for the task with the barrels would make for an excellent solution. Again, I know I've been beaten to it now, but that won't discourage me from having a go. What other things have I still got in terms of code? So there's always things in code that can be made better, and I've been able to build on code from previous years' robots and from code from the books, because they have served as quite a nice foundation for other things I wanted to do. The two are kind of fed into each other, right? So I've been doing the camera line following, and I'll be honest, that PID, I've had to tune it a number of times, and when I switch surfaces the PID needs tuning again, so I may have to have a couple of PID profiles or try and get a surface as close to what the real surface would be as possible. But I have a line following track behind me in the room somewhere over there. Righty. Now I'm going to just adjust you towards the lab, just because that's still family's living room behind me. For those who've seen my lab but hadn't realised that is just the family's living room. There's just a sectioned off space with a large piece of IKEA furniture converted with the tool wall. Right. Now the tricky thing is I might have snookered myself here, because I still need... Oh, there's also that blue tack that's not coming out nice. Let's just get that out. I'm sure blue tack is probably an insulator, but the other thing I don't really have at the moment is I don't really have anything to clean up any of the flux residue on the board. I mean, that's frustrating. But I guess it depends. I mean, I've heard that it degrades boards, and that's not ideal. Right, so we have these two connections. We have this connection here and here. We have this ground connection to there. I need this ground connection. This is where I think I might have snookered myself, because that's not easily going to drop in on top of here without kind of shorting some things. I wonder if so this is where I might again deviate from my original plan and call this ground and this positive, which means that then I could route from here to here and actually cheekily join them topside. Now, is this long enough to A, go from there, and B, poke through that hole? Not quite. I mean, this is through hole plated, so actually if I was, yeah, the insulation's not enough on that. Okay, let's get another piece. Nope. And I've gone and thrown it away. Ha! Lovely. Where is it? This is you know what? It's a bit of wire. And I will always find more uses for bits of wire around here when they turn up. Okay, I'm going to go for something just slightly longer, about that much. So anyone who saw my stream yesterday will know that these were struggling to take off insulation. Without destroying the wire. And now, there we go. It's a bit easier to do here, to be honest, than to do under the camera. Doing it under the camera actually feels kind of awkward. All the angles felt wrong. But the problem with doing it down there is then I'm kind of out of shot doing it. Well, my face is in view, but not the... Okay, now what I'll do is I'm going to put a bend in here. Drop it in there. Oh, I could take a bit more off, couldn't I? Let's take a bit more off up there. No, that was alright. That will do. Well, with that, I can still keep to my design, actually. I can still keep the ground where my plan says it was, which saves me the possibility of getting myself confused later. It's a very real possibility if I start swapping what pins at the end do what. So let's try and stick to the pins I'd planned. Okay, blue tack to stop it moving around so much. tweezers to get it right where I want it. And again, gonna feed this joint. There we go. Get rid of the blue tack and do the other joint. Oh, really? Blue tack's gotten right into that hole there. That wasn't... hadn't intended that. Oh, that's annoying. Blue tack's alright, but it doesn't come off particularly cleanly, does it? I guess I can clean that up later. Right, okay. Let's pop this the other way up. So... this one here. And since it is through hole plated, I can just bend that over to... oh, I see, no, that's the other wire. This is the one I've just added. Okay, right, what I'll do... let's work top side for a little bit. Going to... where do I need space? I need space there, okay. So... if it's not absolutely obvious, although I've done a bit of planning, I am kind of making this up as I go along. Right, now I can bend this over here. Which is coming from the other part of the ground network, and solder that on there. Okay. Right. Am I missing anything? Oh, yeah. Should there be a resistor limiting just how much current gets to those motors? I'm going to look at the original roller design, because maybe one of those things that was a wire between the FET and the rollers, the blue one might need to be replaced with a resistor. I'd totally forgotten that, in which case I can maybe do a resistor across the top of there and make it nice and neat. Right. So let me just... Safari, I'm going to do... give me a second. There we go. Right. So the site that's just appeared was what I've based my Nerf gun on. From its little French Kev, and it's all very video based. Oh, a bit of time. There are some resistors in there, Does he show the wiring diagram with a... Yeah, so look. Oh, okay. No, I see. Okay, so let's just make that bigger for a second, just so everyone can see. So, no, I don't have to worry hugely. So, his green wire there is actually equivalent of my yellow wire, because it's going from the Raspberry Pi signal to the device. And it looks like this is acting as a pull down. And I guess what I'd be doing is just sending a solid logic high and low. Is that really what's going on? Let me just... Data output pull down, or maybe it's, I don't know why there's a pull down there. Well, maybe if you're online later, Kev, you can comment on why that pull down is there. But it's not limiting the current to the motors. In fact, from what I can see, the only thing possibly limiting current to the motors is that FET, which may mean that now he did mention yesterday, and he was on a live stream yesterday, that those roller motors tend to get quite hot. So it might be in my interest to perhaps use, I don't know, PWM and kind of chop how much current and how much on time you're getting on those motors, just so they don't get hot. But we'll see. We'll play that by ear. I mean, if we can find a point where, you know what, if I get a 2 meter distance shot out the front and they don't get too hot at the same time, that would be ideal, but we'll have to feel that out when we get there. Okay, so I guess the real question is, what am I missing? So I have, beyond obviously tidying up, okay, so I've got my... Now, this is the back of the board, and the diagram over to... Oh, there we go. The diagram over here is actually from the front view of the board, so... Just somehow, I've had to reverse this all in my head. So we've got the 3 yellow connections from Raspberry Pi GPIO to the servos up here. We've got this other yellow connection from the Raspberry Pi to the gate of the FET. We have the ground connection with the bar here, and the other ground connection over to what would be from the boost. We've got this bar for the voltage for the servos going across to the output from the boost. In fact, the voltage from the servos is the only thing in this circuit that is driven by the boost output. Everything else is going to be... So, yeah, I mean, there's no other logic on this really beyond the FET, and the FET is either... It's sharing a ground, but it's then taken straight from the Pi. The blue wire here represents a connection from the FET, so that's you got the drain of the FET going to the rollers. You've got ground of the rollers going to the ground of the boost and the batteries. Now the boost shares a ground anyway, so that's actually connected through the boost circuit, which is one of those. This green thing up here is going between... This is actually the battery 3.7 volts output, and straight to what would be the source for the FET. So in theory, gate drain source. I think that's all the connections. I don't think I'm missing anything. So I guess the next trick will be to go and add some things onto this module. So since I've used green to mean the unregulated voltage on that board, and I know it's a bit unconventional, I've used red to mean the regulated 6 volts, or the output 6 volts that this is going to produce. Obviously I'm going to have to go and tweak that up and make sure it really does. This is an adjustable one. So, If you do use, maybe use a high watt rating. Good morning. Hello. Glad to see someone online. Yeah, I guess I'm not yet using it, but yes, you're probably right. One of the bigger chunkier resistors would make sense. Right. So I'm going to go with green and black, just because that then matches the board. Now, I've kind of not really determined exactly where it's going to go. Let me just grab the robot. 1 second. Oh, here we are. So, okay, might be easier to... So this back plane here is going to be first for batteries and then for some of the electronics. I mean, I could put some electronics on here, which is what also Little French Kev has done with his particular his build. The only thing is this is designed to be taken off and replaced with a barrel grabber or something else, which may then use this same server at the bottom for other things. So I might try and see if I can get all the circuits on there. So I probably want to give myself maybe not much more than 5 centimeters. I mean, I don't know. I mean, if they're... So I'm going to be crimping them. So they're going to be kind of modular anyway. So I'm gonna kind of guess at it. I'm making this up. Right, but what I do mean to do for this is that the black and the green will be roughly the same length. So let's do about this much. And actually, because there's the other end of it, which is the black and the red, which I'm going to make ever so slightly longer. Let's go with that long. And start with these ones. I guess you could also let me know how the stream is going. Is my audio nice and clear? You may be able to hear the fan in the background, which is from the iron. Not an awful lot I can do about that, I guess. I've got a fan just so that I'm not getting solder fumes when I do the soldering. There's one. Two. Ah, that happened to me a lot yesterday. So, after yesterday's stream, I now have some strippers that are of both right size and better quality, because these are actually the wrong size. So I've got a set of engineer strippers coming, wire strippers that is, because I quite like the other engineer tools. They're rather nice. So someone on the stream yesterday, I believe it was Mr. Alistair Ware, sent me a link directly to get them. Audio is just fine. Fan hardly noticeable. Voice level is just good. Cool. I think I'm clipping a little bit on the voice, so let me just... I'm just keeping an eye on that VU now you've said it. There we go. But anyway, that's good. That's good if it's hardly noticeable to the voice level. That means that Yeah, nice clear audio. I'm using a headset, which is actually usually my work headset for conference calls at my desk there. So this is a Jabra headset, and actually the audio on these tends to be pretty good. And if you've been following my channel for the number of years, I know that audio is always one of those things that's been, probably for any YouTuber, I guess it's one of the trickier bits. Right. Which way up do I want to do this? I'm going to do it this way up because I'd rather not be working on the same side as the other stuff that's populated. Call me chicken, but so doesn't appear to be anyone else on yet, although I'm not sure how realistic the stats are. Just going to see. There we go. I was just popping something on Twitter to see if I can get a few people to join us, I guess. It is Sunday morning, and I had, after feeling a little bit, I woke up a bit sprightly this morning. I went, right, I'm going to get up and do some stuff. Possibly because I knew this was sitting here, waiting for me to do some stuff. Gives you a feeling like you want to get up and go, right? Go. So one thing I'm wondering about these DC-DC converters, which I don't really have any experience with, is when I dial it in, because I'm obviously going to give it a voltage supply from a battery, try and dial in the other end to give me the 6 volts. Should I have a load resistor to dial it in? Because I'm kind of wondering if it's unrealistic to dial it in when if I've just got a voltmeter attached and no load. Okay, why is that stiff? There we go, that's more like it. There we go. Ooh. Huh. There we go, that's more like it. Where are my pliers? What have I done with them? So sometimes during a build my desk can get a little cluttered. Add to that the chaos of some of the video bits. So I'm not using. Well, I'm using this mic. Normally, sometimes I have a desk mic. This here is actually a presenter, which is effectively a face-down camera on a stand. Let me hold it up so you can see the thing. There we go. And it's really quite handy. It comes with a nice heavy desk weight as well, so it's not going to topple. You have to try. You have to push it past some critical angle to get it to topple. So it's pretty handy. And I've just got another camera. The camera up there is just above the feedback monitor where I can see what I look like. See what OBS is putting out. Right, okay, that's all fine there. The other thing I was going to do, so I think that's all the soldering. So let's turn off the iron. I'm going to use a bit of hot glue around some of these wires for some cheap and nasty load relief. Don't have much experience with DC-DC, but try a load of 20% of the output rating. Yeah, so I'm thinking I should probably have something on there. I haven't given it a lot of thought. So I suspect that will mean I need to dive into, well, I'm going to have to dive into the datasheet for this anyway, right? I mean, you know, that's unavoidable. But that should then, hopefully, the datasheet will have a note on how to dial it in. I mean, seems like an obviously vital piece of information. If it says use a value like this, or resistor in this range, then that would be perfect. Sorry, just cleaning it. Oh, junk there. Okay, hot glue. Oh, I'm trying to do that without standing up. That wasn't going to work, was it? There we are. Righty. Now, the other slight awkward thing in my lab at the moment is, despite me having catalogued where components and some of my tools are, I'm yet to figure out where the extra sticks for the hot glue is. I don't need an awful lot here, just a couple of dabs here and there. And it might be good practice to stick a dab under the FET there. Do I have anything I can stick as a heatsink on that? I don't really have anything I can think of yet. I hear activity behind me. Children are awake. But I don't know what they're up to. Probably doing something on a computer, I imagine. I've let them use their laptops and as in use some laptops, play some online games with friends, and hopefully they can get creative too. Just waiting for this to heat up. Alright, while I give that a chance to heat up, let's go find. So, what's printed on the device? It is XL Semi I need some extra light for that. Oh, okay, light batteries are out. It's XL 600 9E1 for that device. Oh, that's nice and warm there. Let's use that. One thing I really hate with this, with the hot glue, is the stringing. If anybody knows, I don't know if that's just because this is a really cheap hot glue device, or if there's something else that I'm doing that's making it do so grating thing as. Oh, okay, that was a hot corner there. It's quite tricky not to smudge my fingers in it. Luckily it's not. It's not painfully hot, just enough for you to know you've done it. Okay, right. I'm going to get some more on this side because otherwise it's a bit pointless. Okay, that will do. It's not going to be under much strain, to be fair. But I just don't want them not to, you know, work themselves off, metal fatigue and all of that. Okay. So let me just see if I can get this data sheet. Just adding the source in. Window capture. I'm just trying to get it to capture the window in OBS. And I don't know why it always likes to make these as big as it can. Right, let's pop this over here. So the problem is obviously I might need to see if I can find specs for this board and not just the device on it. But the board is just the same. Well, it's XL, so it's the same device, XL 6009E1. Potentially, my expectation is this board is just. There we go. Hold on. I'm expecting the board just to be an application note. I implemented application note. So we've got maximum 4 amp switching current, 5 volt to 32 volt, input voltage range. So hold on, input voltage range of 5 volt to 32 volt. Wait, my input voltage is 3 volts. Have I bought the wrong thing? Let's just go check what I thought I bought, or what I did buy. That would be frustrating. I might have to find another way if it's like that. So I'd have bought this on Amazon, and I'm just going to find in my order history what it was that I actually purchased. Okay, so they say it is a DC 3.0 volt to 30 volt input to a 5 volt to 35 volt output. So it's adjustable step-up circuit board. So this input voltage range isn't quite the same, but is this the difference between 6009 and the 6009E1? Is this because I haven't quite got the exact right data sheet? Well, that's just the part number. Or is that to do with some of this other supporting circuitry that lets it do that boost? Oh, there we go. Okay. Output switch voltage. Electrical input operation voltage. It says minimum of 5 volts on the data sheet. And okay, if I then switch to, can I see that? If I just drop the data sheet for a second. So this is what I bought. It says it's 3 volts to 30 volts input. Not sure you're going to be able to see that very clearly. So that is DSN, good performance, 4 amps. This module is coming with the 3rd generator. I don't know what DSN here is now. That's something else, or is that? DSN 6009, XL 6000. Maybe I can get a data sheet for this DSN device. It's not printed. DSN is not printed anywhere on this board, and it's not printed anywhere on the pack that arrived either. So I don't know where that number's come from, but let's just download that. So I'm found what? No, okay, I've just come back to the same Excel 6009 data sheet. Okay. Alright, let's keep looking. Maybe there's an app note near the bottom that shows how to boost a much lower voltage. Maybe I'm missing something. That's not it. See, that's saying input 12V, 16V, 10V. It's not in the app notes here, is it? This does not really tell me what's going on. And there's no links in that description. Right, what I have found is this. I wonder if I can maybe zoom in there. Okay, so there's a schematic. My guess is that's probably quite close to what we have. You know, there's no component designations on that silk screen. But we have our diode, we have R1, we have... Now we've got a few more devices. So we've got 2 big capacitors, a big inductor, but there's a couple of smaller discrete. So there's a resistor and what look like 2... Hold on, you can't even see what I'm on about, can you? Right, so we got 2 big capacitors here, which looks like the C1 and C2. We've got what looks like the R1 potentiometer here, the coil over there, L1, obviously the device. There's a diode D1 here. There's a resistor which is probably R2, but this is a little bit, it's got 2 capacitors possibly decoupling, or not decoupling actually, that'd be ripple smoothing, wouldn't they? Smoothing capacitors across there, I guess. This is pretty close to that circuit, but it still doesn't tell me whether I'm going to get that. So I guess what we're going to have to do, let me see. What if I make a very simple start with the battery going into this thing, from the battery going into this thing, take the output from this out to, I don't know, just leave it as a couple of wires, and I can go and connect it onto a breadboard and try and A, get the voltage, and B, maybe create a simple load, a resistor or even an LED resistor, so there's actually something being done while I can then dial it in. Okay, hands up, never dialed one of these in before because I've nearly either used AA batteries for motors, and I quite like to use the USB power banks for things like Pis. For the actual robot here, though, this year I also used a boost converter, but I used the Adafruit boost shim that gives you, or not boost shim, what is it called? Lipo boost or something. But anyway, that gives you a regulated 5 volts, which preset, so there's no dialing and there was no worries really. I just had to make sure it had the current rating. Okay, so on the inside I need to go and crimp something. Let's go and move some of these tools out of the way and get the crimping tools on the go. Audio's cleared up because since I've stopped soldering I can turn off the fan. So if I tidy up a tad now, I've got more space to work for the next part of this. I'll pop that over there. Ooh. So what you can't see is I'm tidying up my desk a tad. Just rounding this stuff up to go in the bin. Okay, and if I put the fan out of the way, then where's all the tools I need? Need these engineer crimps. Is where you get to see how laughably bad I am at crimping things. It's a skill I'm still figuring out, and I'm still finding that my hit rate is so on getting good connections. Nope. It's in there somewhere. Up here. Right, I should have. So the other thing you missed yesterday is there's a reason I've got this rat tail and these devices here, which is the rat tail is the, I believe, is it the PH type, I think, or it's the type that will connect to this battery. But I didn't have any of those that I had that were solderable or crimpable, which are the XH type. So everything else I'm crimping on is XH apart from the battery rat tail, which is this other type. I think it's PH, I'm not sure. They're not, unfortunately, compatible. So, I guess now I have thoroughly learned to be very careful with the term JST, because actually I already knew there were different large sizes. There are a bunch of different small size specifications to be wary of. And the best thing ever is to have gone, okay, those weren't the right kind, so I'll buy what I thought was the other kind and find, no, they are the same. So XH and XHP are identical. If you type battery connector, some people will say they are XH. I can say with certainty that the type you get on these lipos are not XH. They're not SM, that's why I'm thinking PH, but I can't remember. And therein lays the problem. I suspect if I remembered it, I'd have got it right. So what do I want? I want housings like that. 1, 2, and there will also be a third for the rollers, but I'll come back for the rollers because I suspect the wire that's on the rollers won't be big enough. And then the other side of this has got the pins, so we want a reel of female housings. I'll start with the reel that I've already taken some off of. Oh. That's quite frustrating. Okay. There's a random bit of tape on that one. Right. Now, so many standards in quotes. Exactly, right? I mean, I can definitely see the advantage of this general type of connection over the general DuPont type. You know, I mean, the DuPont type is fine for, say, some of the signals and some of the servos, but they can work themselves loose, and these are nice and polarized and locking. Wonderful. But the fact that there are so many that are really close. So, I mean, there are two things I noticed between these two, which is first, I believe the one on the motors is 2mm, not 2.54. And you've got for the polarity, I don't know, the tag or whatever you want to call it, the slot. You can see they're just different. There's 2 there and 1 there, just wider. So, yeah, I don't know. I guess maybe if you want 2mm you can get a smaller connector in the same space, but perhaps because I'm still doing a lot of this and not doing as much PCB making, therefore not as much surface mount, I kind of like to stick to 2.5mm. Now this is one of those controversial areas. I like to take these off, which might be one of my downfalls, before trying to crimp them. Some people try to crimp them while they're still on the reel. I don't know, I found that even harder. Again, I am not particularly experienced with this. But the biggest trick here, is going to be just remembering to make sure that they're all crimped the right way up. Because I think that's quite an easy mistake to make at this point, is to end up, you know, up is down and down is up, positive is negative and so on. So I have that diagram, that horrible scribbly diagram in the bottom left there, which if you look at this top side, it almost matches, but I've actually turned that connector round. However, out to boost module, the top here is negative voltage or ground voltage, and it's ground voltage. So that means that I guess what I can do is I can crimp the ends, and then when I push the housings in, get them the right way. Caution when using ready-made cables. Yes, exactly, because your pre-attached cable connectors might be the wrong kind. So I bought the rat tails to exactly match the LiPo, and they do. So, but yes, exactly. I obviously wanted to make sure that I use the same standard as all the LiPos, and I can obviously swap it out for another one without having to go and redo the connections on it. Yeah. Except I went for the pre-made cables for. I mean, the other good thing about rat tails is I'm still terrible at this. Right, let's get ends on all of these. It's this way up. So I think I want to do insulation first. Puff of smoke, harder fruit. Oh, yeah. That's and I mean, with the DuPont connectors, I think it was a little say 8-pin dip package, and it was an I2C little tiny memory, you know, I mean 1K or something, but I was just playing with it because I could, and I was connecting it to an Arduino via a breadboard with a whole bunch of wires. And at one point, I connected it and went and took a break, came back, reconnected it, and it got really hot to the point that I'd kind of had a bit of a brown board. The breadboard was wrong, and admirably, the little ITC device, when connected back the other way, just worked. Yeah, it might have damaged the board, it might have done some horrible things to wires and board, but the I2C module, despite being reverse biased, was just fine. I was quite surprised at that. It's so easily done, and this is why I've kind of gone with these polarized connectors, because I mean, if you're in a state with robots and at an event, at a competition, and you go, right, I've got to swap out the batteries, last thing you want to do, or any other wire, is put yourself in a position where you can let out the magic smoke. I will take it as granted that in such scenarios, I'm just first going to bend those in, then going to put it down that way. Yeah, I just take it for granted that I'm going to be in not the right fit of state of mind to get everything the right way up, and therefore make it foolproof. Part of it also means I could say to, even say to the kids, hey, can you run and change the battery on that without fear of them putting the wrong one in. Although I suppose there's still a potential that there's that many of this kind of connector that they could connect it into the wrong place, but at least they can't connect it the wrong way up. Right, now I think it's the 1.4 I need to go for. We'll soon see. Well, that seems solid. Okay. I'll test that with a multimeter before I house it. I'll try not to forget to do that. So this is one of the tricks. I was using pliers to square these off, but I've been able to square them off just like that, just lightly. So then put them in the other way instead of using pliers, just because pliers tend to deform them more than I meant. I always end up at an awkward angle with this as well. Has that gone in properly? Yeah. Okay. And I just always end up at the wrong angle with this. Always. Is that just me? Cheap eBay. Positive was on left and the board had it wrong. Yeah, you know what I might do? Maybe what I should do with this, maybe I should do this before sticking these in housings. Maybe I should find a way to go and put labels across these. I mean, it could just be paper labels, and then do some nice brightly coloured red, green and black. And I know, again, green's a controversial choice, but just to show it's a different thing. Could have been orange. Right, I need the wire cutter because that's a bit too long, the insulator, the stripped part of that. So the other thing that surprises me about these, for successful crimps, you actually end up with, you need quite a short stripped part, which now I've got wire strippers that are fully functional is a lot easier. I'm sure having, oh no, wait a minute, can't ahead of myself. Yeah, having functional wire strippers is definitely a good start to being able to crimp well. Or include a protection diode. Yeah, that's also a good idea. Because people get nervous about connecting the wrong cables to a computer or a PC, and it's when you go, well, actually, you can't really get it wrong. I mean, for probably about the last 15 years, if you're rooting around inside on the motherboard, maybe it was a different story, but, I mean, that changed. But, if you're connecting stuff from the outside, basically, the worst you could do, I guess as long as you don't try and force in a USB connector upside down, You know, you couldn't really go wrong with them. That's quite nice, I guess. Suppose in the age of the PS2 mouse and keyboard, you could get your mouse and your keyboard slots the wrong way up, and just wouldn't work. It wouldn't break anything. No magic smoke would come out. It just wouldn't get keyboard and mouse working. Oh, you see, now I've ended up at the wrong angle. There we go. Insulator's a bit iffy on that one, but it's going to hold. It's okay. Okay, alrighty. Where's my multimeter? So I'm just going to go start testing, at least that I've got connections that make sense. So sticking into BP mode, which actually I don't know if you're going to hear that through this mic. Yep. Oh, that one's not good. Hold on, I can't quite get a... Gonna hold that to there and just wheel the wire. No, that was just me. Wire's fine. Okay, those are good. That's a good start. Oh, I am Jonathan, yes. Child asking if I'm streaming. Right, going to do the same on... It's alright, buddy. How many are you going to do in a row? I'm just going to do them until I get bored of doing them. Okay. Oop, I'm there. So... That's fine. Of course, that one is actually going to be connected through the this board, because it turns out that this ground and this ground connect through the boost module, which is good. Nice shared ground, makes it easier. Okay, so this point here should be connected to here, which also should be connected to the input voltage here. Yep. Okay. The battery ground should be there, and the battery live should be there. Oh. Okay. Right, found a problem. Glad I checked. So what's going on there? I think that green wire is just plain broke inside. Used to make up IBM token ring cable, huge connectors, massive thick cables, pain in the backside. Yeah, okay. Oh, where you need, is this where you needed the terminator? Otherwise, it wouldn't do anything, or is that a different kind of network? Don't know. So, what about this one to this one? That's fine, but this one to this one, nothing, nada. Okay, that's going to be frustrating. I'll have to desolder that. Let's just check everything else. So these are easy. Yep. Okay. And for the FET, want to know that this one is there. This one goes to which side? I think it's this side. It doesn't go anywhere. Yes, it does. There we go. And that one we already checked from underneath. So that's fine. This one. So that's your blue one, yellow one, green one. So it's just this one wire here that's a problem. Righty. Let's do the labels. I have some labels here. We'll come back for the other bit. Where's a pen? Here's a pen. So boost out. Let's use this to get the scaling. Minus and a little red plus. I can and what I'll do is I'll just cut through it for the other side, I guess, for the other part. I mean, there is a gap of 1, 2, 3, 4. Well, okay. Just keep it simple. In fact, that I'm just going to circle that in green, just so that's kind of clear. Okay. And for the rollers, which side is which? I think my rollers are different from my diagram, and I think I remember this yesterday. So this definitely needs a label, because I think this is here or here. Yeah, so that's your voltage and that's your ground, so there's actually a swap. It's gone in, yeah. And there was a reason I did that, and I've forgotten why that is, but okay, so I am going to cut that bit off. And that means cut that bit off from the label, just in case that was a bit unclear what I meant. So the rollers, so the rollers on this, just to give some background again, are on the front of this device and will actually be shooting the Nerf gun out, Nerf darts out. There is a diode across the top there. I wonder if I can put it under the presenter camera. So they'll only go one way, and also a bit of flyback, I guess, as well, all of that business. But lambs and the cows in there. Lambs and the cows. Don't know about that. So these are, in theory, following the wiring colours that Kev, aka Little French Kev, set out. So I should be able to follow that the red coming from the motor would be the blue here. Wow, okay, I didn't realise you couldn't really see that, what I was doing there. Sorry about that. There we are. So this is going to be rollers out. Okay. Stick the crimping tool over. It was over there. Let's grab these. I guess when it came to actual computing stuff, I was probably mostly more software than hardware. But so generally, when it came to the tech cupboard, mostly it would be we'd ask someone for, can we have a wire from here to here and so on. Yeah, well, I had to go and make that one awkward, didn't I? I had to go and make it so there was one sticking out there. That's fine. Can use those scraps later. And if I need the rest of the board, I'll make something neater, but at the moment that will do fine. The biggest annoyance with these labels is the very distinct potential that they are just going to fall off after a couple of days. This one especially, it might be premature if I'm going to have to go and redo the redo that green wire underneath. Anyway, good morning, Alistair. Good to see you. Right. So that way I know which way up I'm going to crimp things. Or going to pop them through their housings. So for the boost out, if I put... It's a bit washed out. So this light isn't charged, but I have the other light. So let me just pop this one on charge and get another light in, so you get a bit of a brighter view. Never enough hands. Okay, let's angle it down so I don't glare out the main camera. Put that up to... There we are. And I won't forget to put this one on charge, so then I have it for later, because I will regret it if I forget to. So let's do that immediately. So I guess, was I better organised, I would have a set of lights fully charged, ready to go. But now I've... Oh, and this one's absolutely refusing to go into its stand. Control, access units, okay. Lobe attachment module. Lobe? I'm intrigued. What lobe? There we go. Unfortunately, I don't have any video text behind me, so I've got to keep everything going myself, including keeping everything charged. It's just me and occasionally my kids. Right, so it's got to be that way, so the green one should be that way, and I bet you these are... Yeah, they've got to be this way up. There we go. And I'm hoping to get a nice resounding click when it goes in. Yeah. This looks like this is going to come together. Apart from that one cable, I'm going to have to resolder. Oh, why does that one not want to lock? There we go. It's locked. That's cool. And the other one. So that then goes in. Arcane IBM terminology. Okay. I'm going to clip off. There's a great big dag of hot glue that just annoys me. There we go. So that's got to go in that way, which means that's that angle and this angle. There we are. So, in theory, other than the problem we know about, connecting that into... Oh, why does that one want to go? Hello? Oh, it does. It's just resistant. Right, that one in there. And that one in there. I've definitely not really given myself much, have I? Let me just do a wider view. So there's not much space for this to sit somewhere else. There was me wondering if I was giving myself too much, but perhaps not giving myself much. Although, again, I guess the other thing I could do is just pop it down there and just make it a single panel once it's connected. Right, but what I was going to plan to do next was, which would show this was all mostly going to work, if I go from this ground here all the way around to the battery ground. This is where I want. So annoyingly, I have spring, the hook terminals, but I don't have any. Oh, there we go. It's going all the way around through the boost module and out. That's my ground. Beautiful. Yeah, although I have some hook clips, I don't have any adapters that would adapt them to work with my multimeter. So, you know, I guess I've only got these leads. Actually, I have some modular leads, but they're still not quite the right kind to go to the hooks. But it would be really nice to get some. I'll try and figure out. Maybe that'll be an exercise for later. Is try and figure out if I can jury rig how to get some of the hook clips on something my multimeter use. At the very least for the ground, so I could just hook it somewhere. You know, the hook one cable and then tap with the other. Saves me wishing I had more fingers, or hands, not just fingers. I'm going to cut that dag off because it annoys me too. There we are. Right. So I guess this battery voltage here should end up at the green. Is that right? It should do. Oh no, that's the cable we know doesn't work. Okay, fine. And that red output from this should end up GV. Here we are. Excellent. So GV, and the signals we'd already tested earlier. Okay, so that's fantastic. I'm going to take these out for now because I suspect the last thing I want when doing some solder rework on the bottom is extra thermal mass, i.e. that wire. I knew these labels would come off pretty quickly. This one's slightly flapping in the breeze, and however, guess I could just do that. Stuff it. As long as it gives me a rough idea of where I'm going, I don't really need it to be miraculously tidy or anything. Okay, we've got labels, we've got those crimps. I'm going to come back for the motor crimps. Let's move the labels out of the way. I'm working in green. So it's this one here that we're going to replace, which I reckon has just gone inside there. I reckon it's just snapped off entirely or something. We'll have a look. So it doesn't need to be particularly long. That will probably do. Used a paperclip, stiff wire to make a probe. Not very well. Yeah, okay, that makes sense. Yeah, somewhere I've got a literal bag of hook clips. And I have ones with banana plugs, but not... Or do I? Wait a second. So I do have up here. I think I remember the problem now. I have one of these. However, this doesn't reliably sit in the multimeter. It just pops off. And in terms of length, it's this long, which makes it incredibly inconvenient. I guess what I could see is if I've got a male to female banana clip up here somewhere. What have I got? Do I have a male to female banana clip? No, I don't. The only female banana clips I've got, let me see, well, that's female there. What does that go to? Right, so I do have a female banana clip hanging around, or male, I guess. Actually, that is male. Oh no, yeah, that's male. So that's not going to go... We've got the multimeter. Multimeter's female. That's female. So actually I need male to male for that to work. So this one, anyway, this was an old multimeter cable. I'm sure you can see how it perished in terms of the probe went, but I kept the connector around just because it might be useful. So I need male to male. And I think I have a non-shrouded male to, well, whatever, I guess. Aha! We have non-shrouded male to male in the wrong colour, but do I have the right colour? Actually, I do. Huh. So these were handy. I bought these years ago, and which is what I got. It's a set of cable adapters for a bunch of different scenarios and situations. So it gives me those great big croc clips, but on a circuit like this, I mean, those croc clips are going to be mostly too big. I mean, they're still handy, I guess. But if that makes... No, you see, look, that's got absolutely no mechanical... Ah, no, hold on, you can put it... Cut it and extend... It's now useless... No, exactly, useless. Exactly. Right, there we go. Look, that's a nice positive connection on there. Nice solid connection. So if I pop that into the multimeter... That's still quite loosey-goosey. I think that is the Maplin probe kit. I bet you. I visited Maplin quite a lot back in the day. In fact, I can guarantee I bought that multimeter in Maplin. The soldering station. Let's see if I can show you the soldering station. It was the first that I didn't buy in Maplin. Because every other soldering iron before then had either been Maplin or I think a couple had just been given to me when I started out, really, because I was quite young. Yeah, so look, I can hook that in under there and then tap away there and then find that, yes, this is really... There really isn't a connection there. Okay, cool. Ah, very handy. Right, you know what, I might keep it in that configuration while I'm working on this, because that's actually... But I'm going to get all these extra cables that I've just pulled out and put these away. Right, okay. I'm going to raise this camera up a bit, because... There we go. Just because I like the tool wall as a background. It's a nice background, isn't it? Let's put the... Oh, I'm going to put the glue gun out of the way as well. Glue gun is some horrid thing from... I think it's not Hobbycraft. I think it might even just be... it might be Hobbycraft. Yeah. Nice. Well, I've still got. So this was almost definitely a Maplin thing. I still remember buying that one in Maplin as well. I can say quite a lot of the, I don't know, certain amount of the older tooling, electronics wise, would have been Maplin, but I suspect there's an age where it went AV on the bench, DVA. Okay. Is that digital voltage meter? And I guess, I don't know. I'm just guessing here. Right. Oh, I need to strip that as well. So you can watch the glory of wire strippers that don't fail so miserably. Now I've taken that horrible piece of metal out. So the difference is I can actually see it cutting through the insulation now, where before I genuinely couldn't see it going through the insulation. It was just distressing the insulation. Now I can actually see metal. Oh, he says. There we go. Just let the soldering iron warm up. That was not where it came from. Not sure it was supposed to be here either, because those hooks are for something else. Sigh. And those are supposed to be clipped in. I mean, this Uni T jobby has been doing me all right for a while. It's... I don't know, it does the job. I've got voltage, resistance, continuity. I'd probably use... Well, I mean, there are other things. It's also got... I suppose it can measure current. It can measure... In theory, it can measure capacitance and frequency and so on, but I don't really use those as much as I do resistance, voltage, and continuity. And I think those are the three functions that I use most of the time. So, since it does fine with those, and more often when measuring continuity, it's the probes that matter, I think, and voltage. More. I don't know. This one, the Unity hasn't let me down really. It went a bit. I suppose there was a point where I think its batteries got low, and I'd resisted changing them, and then it does misbehave. But I think that's fairly reasonable. Right, I'm going to clip this in here. That's going to be a little bit of a nightmare because where it is. Where did I put my tweezers? I'm probably not the only one who has this experience while making of where did I put my, and having to find that you've got a little pile of stuff. It's why I try to keep putting my tools back where they belong, so then I don't end up with a pile. But it's just too easy to. Did I put them back in there? Yeah, I did. Oh, well, there we go. My tweezers were where they should be. Who'd have thought it? Right. That light is still not quite in the right place. No, it's actually competing with sunlight. That's off and that's on. It is doing something, but there's actually quite a good... It's quite sunny out there, actually. This is where actually nearly forgot. Let's stick my support for the connector underneath so it doesn't start to shrink away from me again, because I don't want a rerun of that. Okay. Let me just... Oh no. Am I still streaming? Sorry, I just hit a button that might have made it disappear. I hope I am. Let me know in the chat if I suddenly dropped off. Old lady's wanting a cable to connect the video and the toaster, and yeah, I mean, I guess also I think Maplin tried to make this transition to, I don't know, competing with Halfords and Currys as well instead, and it didn't really work, did it? Oh, and the batteries. I can't have been the only person that got annoyed with the would you like any batteries with that. It just got a bit incessant. Look, you can see it. You can see it got broke inside. That was probably the issue with the wire stripper. Had mangled this wire so much that yeah, looks okay to me. Still here there. Oh, that's good news. Yep. Yeah. See, the lighting's all wrong. I don't know how to get that light any closer, so but I don't think those two wires are still connected in the middle. I think there's a break somewhere in there. I think that's just, yeah, look, there you go. It's just holding by insulation. So I think when I tried to strip it, at some point I pulled on it so hard that it messed up inside. Okay. What are my chances of threading this back underneath where the original was? I'm probably pushing my luck. No, that's looking good. Okay. My chances are far better than I thought. Alright. Shouldn't need any more solder on this joint. But I might need a little on this one. Because it's looking on... Oh, hold on. Nearly forgot again. Can I up the exposure on this camera? Because it's just so dark. Oh, that's just washing it out. Might be that what I really need is a light coming in that way from the back there. But I don't really have a good place or way in my lab to get that sorted at the moment, I think. I have the lights, I just don't have a stand that would fit in that space. I'm sure I could conjure or build something eventually that would do the trick, but right, okay, let's just go test that. And my multimeter cables have ended up underneath me. Nice. So now... Okay, job is a good un. Right. That board looks like it's ready. Some of this stuff, remember my lovely organised thing yesterday, I've taken some stuff like these out. They don't have a label saying where they go back, so I'm going to have to use my database later to find out where to go. As it stands, there's a little shelf of stuff that should be organised on the back of my desk. It doesn't tend to go down as fast as it goes up, is my general experience. In a minute I might take a natural break anyway, because I think we've gotten to the board works and we need to go and start testing and tuning this up. Plus I suspect I need to go and greet my family before they forget me. So I'll probably pop back online later. When I come back to test these, I'll just turn the camera on and roll, I guess. Well, thanks for being with me while I'm making stuff. It's kind of fun to do it this way, and I think I'm going to do more of this. So cool. Thanks. There's a button.